Hey everybody, Shutsky here again. I'm back. So we're going to go through projects 9 through 16. I'm going to restart my stopwatch here and I'm going to try to do a little bit better job of staying to 1 minute per project. So project number 9. Again, this is video number 2. This is project number 9 through 16. Project number 9 is a smart air supply system for dairy cows using artificial intelligence, but also the Internet of Things. So this is a project where we have the need to work with ventilation systems, air control, air movement, air temperature in dairy facilities with dairy cows. Dairy cows are very sensitive to being comfortable. They want to be kept cool, especially in the summertime when this is the kind of the biggest issue. And we have a number of different technologies for sensing temperature, for sensing air movement, also even now for sensing cow comfort. So this will be the integration of all of that information coming in using sensors and software to optimize those conditions. This is a project that we've had on the books for a number of years now, and the students have made some good progress, including both looking at software applications, but also doing some prototype models, some chambers and other devices like physical representations to validate some of the computer models. It's an exciting project, and it's one where we have a really big need in the dairy industry. That's project number 9. Project number 10 is called a portable bariatric patient lift. So this is actually, we have a client in the Middleton area who is very interested. This person works for the emergency medical services. That's like paramedics, EMTs, and also even in some cases, volunteer fire departments. We oftentimes find these agencies or these services, these organizations going out to help a person. This might be a person who has had a heart attack. Here recently, it could be a COVID person who is having difficulty breathing or some other type of health problem, and they're not able to get themselves up to be transported, oftentimes in an ambulance. And we need to be able to do this safely for both the patient, but also for the responders, because we don't want people having back injuries and other types of problems. So again, working with the client to develop a lifting and probably a transport device, which will allow us to get a person through a lift assist system safely out of a situation and oftentimes into another vehicle like an ambulance. That's project number 10. Project number 11 is also related. Remember, I talked in an earlier project about compost. So when we look here at the city of Madison, Milwaukee, some of our larger urban areas, I'm guessing maybe in the near future, places like Eau Claire and Appleton, we are beginning to see services that will go out to a home, just like you would have a garbage truck drive through a neighborhood, but instead of picking up garbage, they're picking up material that is potentially compostable. I think that that's a word. And so the idea here is early on in this type of an application, early in this type of a business, we want to get kind of a good handle on how much compost is located with each pickup. It's really important for planning, both in terms of like sizing systems, but also just being able to predict the logistics of what happens in a commercial system like this. So the idea here, it's pretty self-explanatory, a weighing system so that when we go from home to home to home and we do pickups, we want to be able to weigh containers. And that could either be a device that's placed on the container itself. It could perhaps be on the lifting arms of the truck or the vehicle that's picking the compost up, or it could be something that's actually located in the vehicle itself so that when you dump the compost in, that vehicle sort of self-weighs what has just been loaded in. So it could be any one of those three or some other method of determining the weight and mass of the compost that they're picking up as they go from home to home. Project number 12 is working with a person, a client, actually Tom Bryan here, who's here at the University of Wisconsin in Madison. He works with some of the facilities like the Leopold greenhouses and other areas. They're really interested in the further development of urban agriculture and specifically hydroponics. The whole idea of hydroponics is to go without the use of soil in tightly constructed places that don't have a lot of access to, well, dirt and soil. So this could perhaps be a greenhouse or some other type of setting. Typically, it's going to be an indoor setting where we grow vegetables, in this case, lettuce or other types of vegetables using hydroponics. Hydroponics are essentially a combination of water plus the appropriate nutrients that are optimized for the particular plant that you're trying to grow. There are systems like this that are available commercially on the market, but the idea here is to develop something that is more simple, that is more attainable for a smaller scale operation. And maybe even when I've talked with Mr. Bryan about this, he's even talked about things where you might be able to buy and source the components at a Home Depot or a Menards, just using standard kind of off-the-shelf components that would be accessible to anybody. We're almost done here. Project number 13 is a portable real-time moisture measurement system that would work for both live trees, but also logs. So trees that they're still technically alive, but they've been cut down, and we've now got logs. Desirable for a whole bunch of different reasons. For live trees, determining moisture content is really critical for looking at how stressed that tree might be, whether or not it needs to be watered, is it in drought or excessive moisture conditions. And then there are also parameters or there are applications where knowing the moisture of that log, if it's a sawed log, is important as you make wood products or you have other types of wood applications or biomass applications that involve trees. So again, a portable system that can be taken out to the forest, to the field, to a sawmill or other locations, and then accurately determine the moisture in real time using some type of a measurement device. Where are we at? Project number 14. Project 14 involves the design of a hydraulic trainer, and these trainers are actually physical workstations that are going to be used in our laboratory in biological systems engineering for student education. We're kind of out of date in this area. There's a number of different design applications where we need to look at things like data acquisition, changing and redesigning some of our valves and other type of equipment. And you can see here, test stands and a large amount of LabVIEW data acquisition are already purchased. So a good project in terms of looking at both data acquisition, but also hydraulic systems, and how those then relate to real world applications, whether it's agricultural or other types of equipment that make good use of hydraulics. Project number 15, we've got two more to go here. Project number 15 is to work with a company here in the Madison area, Delaval. Delaval, their North American engineering headquarters are located in Waunakee. They make a whole variety of different applications, and I would actually encourage you to check out their website. Delaval makes milking robots. The picture that I have here is not a Delaval system, by the way, but robots that milk cows, robots that handle feed, robots that do cleaning, but they also do a whole range of other technology applications. And when I say technology, it's both digital technology, but it's also electrical, mechanical, and even hydraulic technologies to accomplish tasks that are typically very labor intensive. So this will be working with Delaval to identify a high priority project that they have connected to equipment in the dairy industry, and then scoping that project and developing a design and then a prototype in 509 that will meet some of the needs that are connected to Delaval as a company, and also with our advisor who has expertise in that area. Project number 16, this is our last one. I've gone a little bit more than 1 minute per project, but I think I'm doing okay. Project number 16 will be a small team that will work together to develop a mobile hydraulic soil cone penetrometer. So what is a penetrometer? A penetrometer is a device that is used to measure soil compaction in agricultural and other types of settings, including like our yards and other types of property and soil. Soil that is highly compacted is very difficult to work with. If you think about it, plants have difficulty establishing themselves and developing root systems. in highly compacted soil. And it's really good to be able to go out and measure the degree of compaction. The problem is we typically walk around with a handheld soil penetrometer, and we do this like one measurement at a time. And the idea here is a mobile system that will allow us to rapidly collect compaction or data from the soil penetrometer very quickly, to be able to actually map out a field or map out another piece of property and look at its compaction dimensions and its compaction properties. So again, like I said, that's projects number 9 through 16. Keep an eye out. This is video number 2. Keep an eye out. I may or may not have a third video, but for now, you've got more than enough information. I'll provide the link to the spreadsheet. If you want to read more, if you want to follow some of the links, I welcome you to do that. You can also do your own independent research. But make sure that when you select your project, you're giving it some thought. You're really thinking through, like, what is it that I want to accomplish? What kind of a team do I want to work on? What kind of project do I want to work on? And maybe like, what type of industry do I want to work with? I hope this is helpful. Let me know if you have any questions. I look forward to seeing your responses to homework number 1. And we'll stop it there and have a great day.